kind of have a gut feeling, intuition, that this is a jump discontinuity. It's definitely not removable discontinuity. Now, to know it mathematically, what I need to ask myself is, does the function f of x have a limit? Okay? Can I, obviously when x approaches 0, okay? Does it have, as I get to x, whether from I'm going from the right or from the left, okay? What will the value be? So let's try and find out, okay? Let's say when I have from the right, okay? So let's put it f of 1. Okay, f of 1 is 2 divided by 1 is 2. Okay, now let's do f of 0, 5. Okay, or even 0, 1. Okay, 2 divided by 0, 1 is 20. Now let's go to 0, 0, 0, 0, 0, 1. Okay, well, I'm going to get 2 divided by 0, 0, 0, 0, 0, 1. I'll get 2 with 4 zeros, 5 zeros, I'm not sure. Okay. You can see as I make x smaller and smaller and smaller, the y will get bigger and bigger and bigger. Okay? Now, I can never get to a certain number. I won't be able to write down what that limit, because that limit, there is no limit. It goes to infinity. There is no number that I can put here to say, oh, the limit is 10,000. Okay? Because then if I take x which is smaller than a certain value, it will be more than 10,000. I can't even say that it's 10 to the power of million. Okay? 10 to the power of million. Imagine how much is 10 to the power of million. It's 10 times 10 times 10. It's 10 with million zeros, or 1 with million zeros after. Million, not 6 zeros, million zeros. That's still not going to be right, because I can put a smaller x which will be even bigger than that. So we say the function has no limit. Okay? There's no limit. No limit. Now, if the function has no limit, and it doesn't matter whether I'm going from the right or from the left, right? There will be no limit, okay? Then obviously it's not removable discontinuity. In the book, they call it jump discontinuity. That's what they call it. They say it's a jump discontinuity. But really, that is actually not jump discontinuity. A jump discontinuity is like the first function we have. That's a jump discontinuity. Okay? That actually, properly, if you really read maths, that's infinite discontinuity or something like that. You can see the difference, right? Here, if I was a little animal, a little small person, okay, it's not continuous, but maybe I can just jump from one to the other. It's a jump, okay? Or parachute, okay? Here, it's infinity. Okay? It's infinity here. How can I jump? Okay? So these things, this is actually not a jump discontinuity, but as far as we're concerned, AP Maths High School, okay, we'll call these two the same, jump discontinuity, okay? I think I'm going to do one more little example. Okay, so we're coming back again to this function. We've seen it quite a lot of time. Okay, it's the absolute value of x, okay, divided by x itself. Okay, now, if you remember, what we said is, how do we kind of analyze, how do we draw it? We say, okay, f of x, really, this is equivalent, same thing as saying that for x positive, for positive x, it's simply x divided by x, because then the absolute value of a positive value is just the x itself, and that is 1. And for negative x, okay, then the absolute value of a negative number is simply that minus number. Okay, minus negative number is a positive, okay, which is minus 1. Okay, remember that? We've come across this function a couple of times. So if I was to draw it, okay, if I want to draw it, for anything larger than 0, I'm getting a 1. Okay? For anything smaller than 0, I'm getting a minus 1. Okay? What about 0? What about 0? What if x is equal 0? Okay? Well, if x is equal 0, absolute value of 0 divided by 0 is 0 divided by 0. It's not defined. Again, it's not defined. So when I draw these things, I have to be very careful and put that white circle to say it's not defined for 1. Now, we've seen that. We drew that already. Okay? That should remind you something. Now, the question is it continuous? Well, it definitely doesn't look continuous, because if I walk from here, I have to jump. So it's not continuous. Is this continuity removable or jump continuity? Again, it kind of looked like a jump. okay? But why is it a jump continuity? To figure out if it's a jump continuity, you have to ask yourself, does the function have a limit? That's what you're going to ask. Does the function have a limit at x equals 0? If the answer is yes, that means the limit from the right and the left is the same, okay? Then it's a removable discontinuity. But if there's no limit, there's no. Now, there's two reasons why there's no limit here. First of all, if I approach 0 from the right, I get close to 1, okay? If I approach 0 from the right, okay, then I have to use the top one, and that's a 1. If I approach f of x from the left, then I'll get minus 1. So there is no limit, okay, right? But more than that, okay, the function itself, well, this is really it. This is really it, okay? Also, the function is undefined at 0. That's another story. But really, we can already stop here, okay? So there is no limit, okay? No limit, not defined. And therefore, it's a jump discontinuity, okay? Right, I've done all the examples. I just want to give you, they've got some rules for calculating limits. I think I should go over it with you, so I'll make some space. We'll go over that now. Okay, so I'm kind of putting all the stuff that we've come across so far and giving you some simple rules. I'm not saying anything new, but just putting it all together, how to calculate limits, because this is really what we're doing. Okay, so let's say we have f of x is some kind of horizontal function, f of x equals c, straight. Well, that's the easiest case. Okay? In that case, the limit of the function when x approaches a, well, f of x is always c. It's a constant number, so it's always going to be c. So if I have f of x equal 3, then it doesn't matter, the limit in anywhere, for any x is going to be 3. That's obvious. Okay? Next one is a polynomial. Okay? Polynomial. Okay? So let's say I have f of x equal 3x cubed plus 2x squared minus 3x minus 15. Okay? How would I find the limit of x where x approaches, I don't know what, minus 1? Again, not a problem. Well, a bit more difficult here. You can't straight away say the answer. But in this case, as we've done, we just substitute. So minus 1 cubed plus 2 minus 1 squared minus 3 times minus 1 minus 15. I just substitute in the x minus 1. There's no problem. Okay? Right? Where does the problem start? Remember, we like problem. The denominator. And when you have a denominator, then there might be a problem. Or not. Okay? Denominator, terminator. Terminator. Okay? So for example, I don't know what. X squared minus 1. I'm using the same. Well, let's do a little bit different. X squared minus 4 divided by x minus 2. Okay? Now, this is, let's say, f of x. Okay? Now, let's say I'm trying to find out the limit of f of x when x approaches minus 2. Okay? Now, in this case, there is actually no problem. Because I can substitute minus 2 here. There's no problem. Okay? I can substitute x instead of x minus 2. Minus 2 is minus 4. So that's not going to be a problem. That's going to be minus 2 squared minus 4 divided minus 2 minus 2. Okay? So don't think just because of the denominator, ooh, I've got a problem. Actually, sometimes it's no problem. Okay? In this case, as long as you can substitute minus 2 there, then it's fine. Okay? Substitute just like you did in the polynomial. Brilliant. Where is the problem? If, for example, I want to find out the limit of f of x when x approaches 2. The problem comes if I need to approach a number, a value that creates 0 in the denominator. Then I can't substitute. I can't put 2 minus 2. Don't do it. Don't do it. 2 minus 2, 0 in the denominator. No. Okay? What do we do instead? It's still not difficult. Okay? We factorize it. X plus 2 times x minus 2 divided by x minus 2. Cancel. Then, once we got rid of the terminator, the denominator, then we can substitute 2. Okay? Then we're going to write, okay, 2 plus 2 equals 4. Okay? So eventually you will have to substitute once you got rid of the denominator. Okay? Now, sometime it's not going to work. I can think of, for example, you can see here, x plus 5 divided by x minus 1. Okay? Now, you're not going to see me, but you're going to hear my voice. If I put the limit of this function, okay, when x approaches 1, when I approach 1 here, I can't cancel anything. I can't cross-cancel x minus 1. Okay? So there's no definition. I mean, it's not defined. There's no limit. The limit is not defined because I'm going to have a 6 divided by 0. It's infinity. Okay? We have an undefined limit. Okay? Split function. Okay? So split function, I'm not going to show how much you can see here. Okay, let me just pause you. No, I can do it. Okay. So let's say f of x equal, I'm not going to do the whole thing. I'm just going to remind you. So let's say I have x for x larger than 1. Then let's say I have 2x for x smaller than 1. Okay? You can do that. I'm not going to even draw it. You can think about it. But if I have a step function, okay, and I want to calculate the limit, then I need to calculate the limit. Let's say at 1 from the positive, okay, from the right side, and I have to calculate the limit from the negative side. Okay? If I go from the positive, from the right, then I have to use this definition. If I'm finding the limit from the left, I have to find this definition. So it depends what they're asking you. If they're asking you the limit from the right, you've got to use that. If you've got to use the limit from the left, you've got to use this. Okay? Then they might ask you, is there a limit? Remember, limits only exist if these two limits from the right and the left are the same. And if they're not the same, then there is no limit, and it's not a removable continuity, it's a jump to continuity. Okay, guys, I hope you enjoyed it, like I did, or at least, or maybe even more. Okay, yeah, I enjoyed it. So now you can do exercise 4.1 and 4.2. Okay, we'll hear from you. Please send me question on WhatsApp. Don't wait for for our lesson. You know, the reception is not so good. So send me a question. Anything you can't get, put it on the group. Maybe somebody will answer, and if not, I will. Okay. Cheerio, and I'll see you next week.